So this is the video for Chapter 3, Activity 1, Part 1. I just want to walk you through the materials that I have here with me. I have two metal cubes. One is a shiny metal and one is a matte finish. We'll call the shiny cube Cube A and the matte finish Cube B. We have a lump of modeling clay here. We have two graduated cylinders which can hold up to 250 milliliters of liquid. They are currently both filled to 150 milliliters of water. And then I have a digital gram scale here. So I'm going to walk you through a couple of scenarios in which you are asked to think about these materials and make some predictions about what will happen when they are dunked into the cylinders of water. And what I want you to do is pause the video when I tell you to, and then write your predictions down, and then play the video again when you're ready to see what actually happens. So the first thing that we're going to think about is what happens when these cubes are placed into the cylinders of water. So remember, like I said, these are two metallic cubes. Cube A is shiny metal, Cube B is a matte finish metal, and they feel different. To me, I would make a hypothesis that these are different types of metal because they feel really different when I pick them up. I wish that you were able to do this experiment yourself, but unfortunately, this is what we have to do with the video. The other prediction that you're asked to make is about this modeling clay. Maybe you're familiar with modeling clay. It's pretty light. You can reshape it into, sort of whatever form you want. You can imagine it kind of like Play-Doh or silly putty, but it doesn't dry out. It stays nice and soft. You can break it into smaller pieces. You can form it into shapes. This one is just rolled into a ball, and it's pretty light. Okay, so again, the first thing that you're asked to think about is what will happen to these cubes when they are dropped into these two graduated cylinders of water. So go ahead and pause the video now and write down your prediction. Okay, now that you've made your prediction, we can go ahead and do that experiment. So what I'm going to do is I'm going to take Cube A and I'm going to gently slide it into the graduated cylinder. And remember, we've noted that the water level is at 150 milliliters. I'm going to try and slide this in gently so that we don't have a big splash. Okay, we didn't lose any water. And as you can see, the cube sank immediately down to the bottom and the water level rose. So if I set this down here on the table to read it accurately, the water level is at 166 milliliters. Okay, so let's go ahead and do that same experiment with our other graduated cylinder and our other cube, Cube B. Again, I'm going to let this slide in gently so that we don't splash any water out of the cylinder. Okay. And again, it sank immediately to the bottom. And let's read our water level. And the water level is also 168 milliliters on this second graduated cylinder. Okay, our next prediction that we're asked to make is what will happen if we drop this ball of modeling clay into the graduated cylinder. So I'm going to let you pause the video like you did before and write down your prediction. Okay, so you've made your prediction about what will happen to this modeling clay when we drop it into the graduated cylinder. I'm going to start with the full chunk and see what happens. I also have a much tinier piece that I pinched off while you were making your prediction. So let's go ahead and see what happens. Okay, it sunk. Again, the water level was at 150 milliliters when I did that, and it's currently risen to 156 milliliters. Okay, I'm not gonna pull that out. I'm just gonna go ahead and dunk the tiny little piece in. This is much smaller than the first piece, so let's see what happens. All right, that one also sunk. So you can see both of them there right at the bottom. And just to check, the water level barely shifted. Almost, it's almost impossible to read how much it shifted after I dropped that tiny little bit in. So those two demonstrations should be good for part one. Go ahead and finish up those questions, and then you can move on to part two.